Welcome to the video on complex numbers part 1. In this video we're going to take a look at how we can solve some quadratic equations where we run into some issues because we have negative numbers inside of a square root and how we deal with that. So let's take a look at a possible example. That's kind of a basic example to start off with. If I have x squared equals negative 1, let's say we want to solve this by taking square roots like we did in the last section. If we do that, we're going to have x equals plus or minus the square root of negative 1. But you may or may not realize that we have a problem here. There is no such real number that will work to solve this equation. Let's kind of rewind here for a second. If we just think about what's going on and we're solving x squared equal to negative 1, we really are trying to find what number, when multiplied to itself, gives us a product of negative 1. And you might be thinking, well, what if x is 1? And you may not be thinking that, but let's say you are. Well, 1 times 1 equals negative 1, and that is not going to work because that is just simply not true. 1 times 1 is 1, not negative 1. And then you say, well, what if x is negative 1? Well, you're close, but if you do negative 1 times negative 1, you don't get negative 1 as a product. Remember, two negatives multiply to make a positive, and you end up with 1 equal to negative 1, which is also simply not true. There is no real number solution to this problem. So this is interesting. We can't use a real number, so if it's not real, well, we have an imaginary answer. Now, this imaginary answer is all based on something mathematicians defined as the imaginary unit. This imaginary unit is I, and it's defined as the square root of negative 1. So we can answer this question now, and let's first maybe talk about some of the properties of this imaginary unit based on the definition. If you recall, if I have square root of a number times square root of a number, I just get that radicand. So if I have I squared, really that's like I times I, right? Based on the definition, that's the square root of negative 1 times the square root of negative 1, which, based on this definition, I just get the radicand negative 1. So what I'm telling you is, if I have the imaginary unit squared, I just get negative 1. This is a property that we're going to use over and over again when we simplify using the imaginary unit. Okay, let's take a look at a couple of basic examples. So, example 1. Let's do a couple different parts here. Part A, if I want to simplify the square root of negative 5, I'm going to do it the long way first. Using the product property, I can say this is the same as negative 1 times positive 5, which, using the product property, I can separate and do square root of negative 1 times the square root of 5, which, now that we know what to call the square root of negative 1, it's the imaginary unit I, we can just say this is I square root of 5, or I times the square root of 5. In general, not in general, if I can make a G, in general, if I have the square root of a negative r, where let's say r is bigger than 0, just any number bigger than 0. So I have the square root of a negative number. You're going to get I times the positive square root of r. So this is going to be very valuable for us. Let's do one more example, but rather quickly this time. If I have, let's say, the square root of negative 7, what a lot of students do, and what I'm going to say as a shortcut to this formula is, hey guys, anytime you have a negative inside the radical, I like to poke an I out, meaning I'm going to have an I outside of the radical, and I'm just left with the positive 7 as my radicand, and it's simplified. Let's look at a couple more examples on the next slide. Let's do another one. Let's say I have the square root of negative 9. Well, I poke an I out, right? And I'd have I times the positive square root of 9, which is going to be just I times 3, which we're going to write this as if it were like a variable, right? We would want to write the I behind the 3, so it's like 3I, or 3 times I. Let's do one more where something interesting happens. Let's look at D. If I have the quantity I, let's say, square root 3 squared, now I'm going to do this the long way, and then I'll show you a shortcut. Really what that means is I'm going to do I radical 3 multiplied to itself, right? Now, if I'm multiplying all of these numbers together, I can multiply in any order I please. So I can do I times I, so I can do the I times the I together to get I squared, times radical 3 times radical 3. So radical 3 times radical 3. Now, remember on the last page or above, I squared is really the number -1. Remember, I squared equals -1. We can use that here. So if I squared is -1, and you recall what radical 3 times radical 3 is, it's just 3. I have -1 times 3, or -3. In general, I'm having a really hard time making my G's here. So in general, if I have I radical, let's just say R, quantity squared, I'm just going to have -R at the end of the day. So let's take a look at E. Let's apply the shortcut, this in general shortcut here. If I have, let's do I radical, I don't know, 17, and I have it squared. Using the shortcut, I know I'm just going to have the opposite of the radicand 17. That's it. I don't have to go through all of the elaborate work that I did in that example if I don't want to, if I remember this general formula. Let's solve a couple quadratics where we actually have to simplify on the next slide. So let's go with example 2. I think we're on example 2. I'm going to try to solve a quadratic equation here. Here we go. Let's solve 3x squared plus 10 equals -26. We're going to do the same exact thing we did when we were solving by taking square roots, beginning with isolating the squared term. So I'm going to subtract 10 to begin with, and the 10 minus 10 are going to cancel, giving me just 3x squared equals -36. Now I'm going to divide everything by 3, and if I do that, I'm going to be left with an x squared on the left, and -36 divided by 3 is -12. Now I'm ready to square root both sides, so I'm going to square root, and I get x equals, and just like before, I'm going to do plus or minus the square root of -12. However, now I have the tools I need in order to simplify when the square root is negative. So I'm going to poke the I out, so I get plus or minus I square root of +12. Now if I can, I'm going to apply the same rules that I remember from last section, which if I break 12 down into 4 times 3, there's my perfect square number 4. I can really have this as plus or minus I, and if I have the square root of 4 and the square root of 3, this will become plus or minus I times the square root of 4, which is really the number 2, times the square root of 3. Now the way we would want to write this is in the following order. I'm going to have plus or minus 2 first, then I, followed by the square root of 3. The reason why we want to do that is, and we want to write all this stuff in front of the radical so that we don't think, let me just show you, if I wrote radical 3 first and then a 2i, it may be confusing to know whether or not that 2i is inside as part of the radicand or not. So always end with your radical when you have a radical with other numbers or variables involved. So here we go. This is our imaginary solution. This is an imaginary solution. It's got the I in it. Let's do another one on the next slide. Alright, we'll end with one last example. Let's call this example 3, where I'm going to solve 2 times the quantity x minus 1 squared plus 10 equals 0. Same idea as the last section. I'm going to isolate the squared term. So I'm going to subtract 10 from both sides. And I'm going to have 2 times the quantity x minus 1 squared equals negative 10. Let's divide everything by 2. And I get x minus 1 quantity squared equals, that's a negative 5. At this stage, we would square root. So I'm going to have x minus 1 equals plus or minus. Now remember, if you have a negative inside, I'm going to poke an I out, and I don't have to simplify radical 5. But what I do need to do here is add 1 to both sides to get the x completely alone. And so I end up with 1 plus or minus I radical 5. This really is 2 solutions. Remember, if I wanted to separate them, I could. It's 1 plus I radical 5, and then 1 minus I radical 5. These are my 2 imaginary solutions here. Thanks for watching.